Okay, so this is from chapter 5 in my macroeconomics textbook, and we're going to be looking at why the marginal rate of substitution, what's the relation between that and the marginal utilities. So there's a small calculation in the text there. So we're going to go through that step by step. Okay, so we have there's a utility function that we're given. So in this case, we're thinking of utility as dependent on consumption of two goods, entertainment E and food F. Okay, so that's utility function. And we remember that the indifference curve is a combination of goods, E and F in this case, such that utility is constant. Okay, so it says something about how we're willing to trade off one good against the other. Okay, so something like E and F here, saying that how we're willing to exchange one for the other. Slope of the difference curve, the marginal rate of substitution, will depend on where we evaluate it. So it's steep here, flatter down here. Okay. So the question, in some sense, is can we say something deeper about that slope, what it says about how we're evaluating these different goods against each other? And we can. So we're going to be using a tool from mathematics, or tool technique, that we totally differentiate this function. Say, we let everything change. The whole sea is changing here. Everything is changing. And we're going to be using some notation to do that. So use D to denote a change. Okay, small change in terms of differential, but a change. And we're going to be using little delta expression like this, delta U of E of F over delta E to denote a partial derivative. Okay, so we have this function U that depends on E and F and parameters. What's a change in utility if I'm changing E just a little bit and keeping everything else fixed? The partial derivative. Okay, so it's a function of several variables, and we're changing one of those only and seeing what happens to the dependent variable. So, to take an example of that, assume that the utility function has a particular form where it's say E squared times F squared. Okay, very simple form. So if we're taking the partial derivative of that utility function with respect to E, we're just differentiating this animal here with respect to E. So it's raised to the power of 2. So the 2 comes down, okay, raised to the 2 minus 1, so that's just 1. And F squared, we said we're keeping everything else constant, so that's just treated as a constant. So this is a partial derivative of utility with respect to E, okay? So that's just preliminaries for notation. Okay, so let's get going with the total differentiation, where we let everything change. So here we let utility change. What's a total change in utility? Well, that's given by the change in utility that comes from the marginal changes in E, so the partial derivative of the utility with respect to B. So we're letting, so what's a total change in utility? Well, it depends on how much E and F are changing and the impact of those changes. So here, there's a change in E, and how that is impacting utility was keeping F fixed, and then we want to let F change as well. So E of F df times df, like that. Okay, so how does utility change? Well, it depends on how much E changes and the impact of that, and how much F changes and the impact of that. Okay, so if we're along the indifference curve, we're on the indifference curve, we're letting these things change, what do we know? Well, we know that the change in utility is equal to 0, along the indifference curve. Okay, so we can use this expression. We can move this term over to the left-hand side, which will give us an minus d ue of f dE, like so. df and times df. And then divide through by this and divide through by this to reach that minus dE df is given to what? Well, it's du of E of f df, like that. Du E of f dE. Okay, so what does this say? Well, what is this thing here? Well, it's, if we have E, F here, there's an indifference curve. So dE dF here would be, as we're moving along the indifference curve, what's the slope? Okay, so these would be for a large change. For small changes, we would be looking at the tangent, right? Or in other words, this is the MRS, the marginal rate of substitution. It's given by that. And what is this in words? Well, it's marginal utility of food over the marginal utility of entertainment. Okay. So in a case like here, where it's relatively steep, we will have a high marginal utility of food relative to the marginal utility of entertainment. It's like I'm, relatively little food. I'm hungry. My utility, my valuation of getting an extra unit of food relative to an extra unit of entertainment would be high. Okay. Whereas down here, I'm pretty full, but whatever. I can always take one more apple. So my marginal utility of additional food is low relative to my marginal valuation of marginal utility of additional entertainment. I'm bored. Okay, so that's it.